Hi, let us look at pros and cons of MergeSort. First, look at pros of MergeSort. MergeSort is suitable for very large size list. If you have millions of numbers, you can sort them using MergeSort. Or if you have millions of records, you can sort them using MergeSort. No other sort can support very large size list. I'll give you the reason afterwards. So it is suitable for large size list. MergeSort is suitable for linked list. For example, if I have two linked lists, I'll explain how MergeSort is suitable for linked list. See, MergeSort uses merging. So if we understand merging upon linked list, then MergeSort also works similarly. See, if I have two lists that are sorted, two linked lists, I can merge them without creating third linked list. So I can just link these nodes and form a single linked list. So two linked lists can be merged by just changing the links without creating third linked list. So if I start comparing the elements, I start the merge process. 2, 3, 2 is smaller, so 2 should be the first number. Next is 3 is smaller, so it should point on 3. Then 3 and 8, right? So 3 and 8, 3 is smaller. Then 8 and 9, 8 is smaller. So this 3 should point on this one. Then 8 is over. 9 and 12, which one is smaller? 9 is smaller. So 8 should point on 9. Then 10 and 11, sorry, 12 and 11, which is smaller? 11 is smaller. So the same thing is there. Then next is this one. So that's it. We have a single sorted list. If I start from here, 2, then 3, then 8, 9, 11 and 12. So it is sorted. Without creating third linked list, I have merged two linked lists. So I can also perform a sort over a linked list without creating another linked list. MergeSort supports external sorting. Actually, merging process supports external sorting, so also MergeSort. So what is this external sorting? For explaining external sorting, I have taken a hard disk here. This is a hard disk. It is having two files, and these are having some data. Imagine they are having millions of records or millions of numbers. These two files are very big. Say this is 5 GB data and this is 10 GB data is there in these two files. These are very big files. I want to merge them. If I can merge them, then also I can perform MergeSort because MergeSort follows merging. Let us see. These files or the data of those files has to be brought in the main memory, then only merging can be done. So let us say RAM. I should bring this two files in the main memory, then only merge algorithm running here can merge those two and store the result in the third list. But size of my memory is just 4 GB. Can I bring those two files, 5 GB, 10 GB? No, I cannot bring entire file in the main memory. Then how merging can be done? So I can bring the part of a file and merge and then store the result here. So I can bring that file in pieces, in runs or chunks of file. The pieces of file I can bring. So here to show you, I can show that just I'll bring number 2 and then number 3 from two files, first file and the second file. So imagine that I have brought some group of numbers or a block of data. Imagine that. Now I have this data. Compare which one is the smaller, 2. So 2 will go here. Now the data from this file is copied there. You bring the next data of that file, 10. That's it. Now compare this, 3 goes here. The next element from this comes here. So I am showing in terms of elements, but you imagine them in terms of some group of elements or group of records or blocks. So I can bring few blocks here and merge them and store the result. So I need very small space here. I don't need 5 GB or 10 GB, total 15 GB of space. This is external merging, and external MergeSort uses the same method. So MergeSort can sort large size data using external merging. Merge sort is stable. What does it mean by stable? If I have a list in which I have some duplicates. 8 is duplicated, so it is appearing 2 times. I have taken one in small size, one in large size to show that this is first 8 and that is second 8. After merging, how I want the result is first, then 4, 5, 6, this is small 8, then this 8, then 9. So if you see here, after sorting, the order of duplicate is maintained. We did not get the array like this 3, 4, 5, 6, that 8 first, then this 8, then 9. No. We got them in the same order. This was first 8, that was second 8. So their order is maintained. So for the numbers, we cannot figure out why, what is the importance of that. Imagine this is the record. This is students' data. And these are the marks obtained by the students in particular subject out of 10. Now already the data is having some arrangement based on their name or roll number. Somehow the arrangement is there. Now I want to sort them based on marks. The previous arrangement should not be disturbed. So this 8 comes first, then that 8. Suppose this record belongs to Ravi and that records belong to Sunil. So Ravi's record should come first and then Sunil record should come. That's it. That's the stability. If already you have some arrangement of data and you want to sort it, then if there are duplicates, then they should preserve their order. So MergeSort can do that better. MergeSort is stable. Now cons of MergeSort, drawbacks of MergeSort. First is it needs extra space for sorting. It is not in place sorting algorithm. What does it mean by in place? See, if I have a array of elements, I have to sort them 6, 3, 9, 4, 10, 12 and I want to sort them. Now sorting algorithm should rearrange the elements within a same array only and sort them. If it is rearranging within a same array, then we call it as in place sorting. MergeSort is not in place sorting. For sorting this one, we have to merge the list. We'll break the list into pieces and then we start merging. You know the algorithm. So for merging, the result has to be kept in a separate array. Merge results cannot be within same array. In place merging cannot be done, so in place sorting cannot be done. So we need some extra array. It needs extra space and only in case of array, not in case of linked list. So MergeSort is not much suitable for arrays. It needs extra space. So in place sorting is not possible. You need extra space. Next one is no small problem. We have seen the algorithm for MergeSort. There was no small problem defined. We say that the problem is large. If it is large, we break it into small sub-problems, to half sub-problems. And when it is small, if there is a single element, it is small and we don't do anything there. So it's not having small problem. So because it is divide and conquer and it is recursive, it is observed that for small size list, it is slower. For small size list, it is much slower compared to other sorts. So example, insertion sort. Actually, insertion sort takes order of n square time and merge sort takes order of n log n time. Insertion sort is n square and merge sort is n log n. So merge sort is much faster than insertion sort. But it was observed that if the size of a list is very small, then the merge sort wastes a lot of time in recursion and it is becoming slower compared to insertion sort. When you really run two algorithms on a machine, on a computer, we find that the merge sort is slower if the list is small. So it is observed that for the list less than or equal to 15 number of elements, merge sort is slower. After that, the list is larger, then merge sort is slowly better than insertion sort. So what we do is, for small problem, if the list is small, we assign it to insertion sort. So we use insertion sort as a part of merge sort. So merge sort will not sort small list, it will take the help of insertion sort, and the results it will merge. Now next, why insertion sort? Because insertion sort is also stable. That is the reason we use insertion sort along with merge sort. Is there any other algorithm that is stable? Yes, bubble sort. Bubble sort is also n square and it is also stable. In place of insertion, we can use bubble also. But merge sort is suitable for linked list and insertion sort is also suitable for linked list. Right? So actually I am discussing about merge sort and the problem with the merge sort. And I have not discussed about insertion and bubble. So you can find it in another video where I will be analyzing all the algorithms. I'll comparing all the algorithms on various criteria. So here for solving merge sort, for small problems, we take the help of insertion sort. The last thing is insertion sort is recursive. And all recursive algorithms use stack. They use stack, that is stack in the memory. Then merge sort also uses a stack. So what could be the maximum size of the stack? The maximum size of the stack depends on the tracing height of a tracing tree of merge sort. Right? So in the previous video you can find a tree of merge sort and it depends on the height of that tracing tree of merge sort. So if you remember, if the 8 elements are given, then it will call itself for 1 4 and then here 5 to 8, then here 1 to 2, then here 1 to 1. So what is the height? It is log n. So the height of merge sort or the working, if you see, the height is log n. So how much stack space it needs? Log n stack space at a time it needs. It may be creating many activation records, but the maximum activation records will be log n. So it needs space in the stack. And also it takes extra space for auxiliary array, extra space. Extra space size should be n and plus that stack space is log n. So merge sort takes n plus log n space. And asymptotically when you take, you can take it as theta of n or big O of n. N plus log n is the total space taken. What is n? This extra space, and log n is the stack space. So that's all the pros and cons of merge sort. So you can watch my previous video. And one more thing is, if you're watching video for merge sort, first of all you watch a video on two-way merge sort. Then you can follow merge sort. I have splitted the video into so that it should not become a very big size video. So you should watch first two-way merge sort, then merge sort, then the analysis of merge sort.